Okay, then we have different types of communication. Okay, so total 4 types we are going to see here: unicast, multicast, broadcast, and anycast. Okay, these are the 4 terms. We have unicast, multicast, broadcast, and anycast. Okay, how many of these things you know out of 4? Unicast, multicast, broadcast, anycast, everything you know. Correct. Okay, let's see. What is a unicast? 1-to-1. What do you mean 1-to-1 communication? This is simple notation. Okay, 1-to-1 communication. But what does it mean with 1-to-1 communication? Router to router. Okay. What about router to switch or router to PC? Correct. There is only one sender and one receiver. Number of devices fixed. That here in unicast, only 1-to-1. There is fixed that one is the sender and one is the receiver. Now they can exchange the information. Only one sender, only one receiver. That is your 1-to-1 communication, unicast. Okay, what about the multicast? Give me an example for unicast. Daily life example, anything? Walkie-talkie. Okay. So in walkie-talkie, only one person can listen. Okay. What about your normal phone call? Unicast. What about your WhatsApp personal chat? If you're texting only one friend, that is what? Unicast. Correct? Okay. What is multicast? You'll say one-to-many. Correct? One-to-many communication? No. One-to-many, but not all. We are communicating with more than one this time, but not with everyone. Correct? Okay. Let's say, for example, I have lots of students. Okay, morning till evening, I have the batches. But I want to deliver some specific information to your batch only. Now, what kind of information it will be? Multicast. I'll be creating a group, right? And in that group, whatever information I'm delivering means the sender is one, but the receivers are many. But how do you decide the receivers? They will be part of a group. Okay, means we are having communication with one-to-many, more than one, but we are not having the communication with everyone, right? Here, right now on the 3rd floor, multiple classrooms are there and classes are going on, right? Lots of students are there. But whatever information I'm delivering, that is reaching only this classroom, not going out of this classroom. This is multicast. Okay, so one-to-many, but not all. Or you can say that only to selected people, selected nodes. Communication with only selected nodes. Okay, out of all the nodes, we have selected some and then we are communicating with them. Okay, clear? Okay. What is broadcast? One-to-all communication. One-to-all communication. Okay, one-to-all communication means, what does it mean?
Channel broadcasting the channel. So you simultaneously you can see all the things. So you record the data, but you will change to the.
Correct. If someone is shouting outside, that information is not relevant to us, but still reaching us. Why? Because it's a broadcast. Okay. Or let's say if I want to deliver some information to entire class. So right now I'm using my voice. So it is what? Broadcast, because everyone inside the classroom is able to get that information. Okay. So one-to-all communication. Now, if there is a student who is standing behind the door, he will also get this information. Is it relevant to him? No, but he will still get the information. Okay. So broadcast is one-to-all communication. Okay. Then we have Anycast. Now tell me, Anycast.
The Sunday can send the information to you.
Anyone?
Maybe he can send a single or money or all. Maybe.
Okay.
Those who are requesting.
Those who are requesting. Anything else? Anycast? No. Looking at the diagram, you can tell me. One-to-one communication. Anycast is also one-to-one communication. But now there is a problem. What is the problem? Unicast also one-to-one. Anycast also one-to-one. So whenever one-to-one communication, we should call it Unicast or Anycast. Right? Now, see what happens in case of Anycast. First of all, this Anycast is a feature of your IPv6, not in IPv4. Okay. In IPv6, there is an address, specific type of address that is known as Anycast. Now, in that address, what happens? See, multiple nodes. Okay, multiple nodes will share the same address, means same IP address configuration. There will be same IP address configuration on multiple systems. Now, this is kind of scenario when, let's say, this is your colony and all the houses, they are having the same address, same plot number, same, like it's kind of everybody just copied, pasted the nameplate. Now, when a courier person comes to deliver the courier, when a courier person comes to deliver the courier, where he will deliver? Whatever nameplate, let's say there are houses in the sequence, for example. Okay, this is a colony and there are like houses in the sequence. Okay, he's coming from this side. He has to deliver the courier. He will look the nameplate. Found, deliver it. Will he check these houses? No. But what if this address is different? He'll walk here. He'll check the address. Okay, same. Give it. Means he does not care who is the destination, but he will deliver it to the nearest one. According to him, whatever he finds first, to that node, it will deliver that date. Now, let me give you a real-time example that where this happens. Okay, let's say you want to access Google. So in India, when you want to access Google, what you write in your browser? Google.com. In your browser, you go and write google.com. Correct? You write this thing in India. What if you are in US? What are you going to write? Google.com. Okay. In US also, you'll say google.com. What about UK? Everywhere you are going to provide the same address that I want to go to this particular site. Now tell me, are you going to get connected to only a single server? Is a single server possible? Like, is it possible for a single server to provide service to entire world? No. Why? That means your Google has established different servers around the globe, right? So when you are accessing through India, when you are accessing from India, you are getting connected to the server that is closest to the India or in India. That server is providing you the service. Now, let's say due to some reason, India server is down. Now you will not directly get connected to the US server. No, it will look for the nearest one. Yes. That which one is the nearest. And that server you will get connected to. So sometimes you are able to access Google faster and sometimes you're able to access it slower. Why? Because when it is slower, you will get connected to some different server. Okay. So this is when same address is being used on multiple nodes. And whenever it comes for the delivery of the information, that delivery will be done to the nearest host. Okay. So how you can say it is in case of Anycast, multiple nodes share the same address. Multiple nodes share the same address. And the masses is delivered to the nearest host. Is delivered to the nearest node. That is your Anycast. Still one-to-one communication because one sender, one receiver. But this time, the receiver is the nearest one. Okay, this is clear.